Hi everybody. I wanted to do a quick demo of a new software toy that I have, which is called Github CoPilot, and it's basically an automatic code generation. It uses artificial intelligence to generate code based on the programmer's intent as expressed by comments and function names. So this should cut down the amount of time needed to do simple tasks tremendously. So I'm going to start off and just a couple things about the environment. This is running in an Anaconda notebook on the Microsoft VS Code editor. So you have to use a couple specific editors for the plugin to work. So that's what I'm using. It still is a standard kind of Jupyter notebook that I'm going to be doing. So let me start with imports. So I'm going to do import pil.image. And notice it's kind of completing in things for me, NumPy. VS Code is pretty good. And yeah, matplotlib. Those are always good things to start with in any type of scientific package. So we'll just go ahead and do that. So what I'm going to do is just type import and yeah, NumPy import matplotlib. And you've noticed it's doing some autocomplete here. That's a little more sophisticated than you probably find with a standard editor. Yeah, and I'm just doing as image. So I'll go ahead and execute this. Just shift return and have it done. So it's imported everything, which is awesome. Now let's actually try doing some kind of program. So one of the things I always like to do is like Mandelbrot sets. It's a cool kind of visual display. So let's do this. Let's return the value of a Mandelbrot set at a given x, y, coordinate position. That's fine. So I'm going to type def and just see what it does. So it's filled in the code for me. So if you notice, it says Mandelbrot XY. It's doing the complex iteration. It's actually changing it into complex numbers, which is what it's supposed to do. The ij is an imaginary number, and the z is in there as well. So this is doing an iterative map of doing this up to 100 different times. Let me actually see if there's other options for this. I'm going to look at some other code options. Yeah, this is pretty good. So it's doing a depth of 100 iterations. That's kind of about what I wanted to do. So I'm going to go ahead and hit tab, and I'm going to execute that cell. So we've written the first section of the code for Mandelbrot set. Next thing we want to do is create a Mandelbrot set image. It knows that I want to do that already, so we're going to do that. Create a Mandelbrot set. I'm going to make it a color image. With a pretty color scheme. So what I'm doing is being a little more specific. It tried to anticipate what I wanted, but I wanted something a little nicer. So I'm going to go ahead and do that. So I'm going to type in def and see what it does. And what's it doing here? So that looks like it could be pretty. It has a bunch of different colors. The little 255s down here are assigning different colors to this. And is it creating an image? Well, it's kind of creating an image. It's going to do that. So yeah, let's give this a shot. See if this works. Let me take a look at some other options before I do. Oh, that looks pretty. So this one's doing a little bit better. This is actually showing the image. So I like that even better. So I've just looked at some different alternate codes that it's come up with. And it's, again, using some Googling and things in the background to do this. But it looks like it's doing some pretty cool things here with the colors. So I'm going to go ahead and do that. So I'm going to tab. And let's take a look. So this is called, what's the function called? Mandelbrot set. So let's take a look. Mandelbrot set. Yeah. 1,000 by 1,000 with a maximum number of iterations. Sure. I mean, the maximum number of iterations, 1,000. That's a lot of iterations. But let's cut it down to 100. I just want to do 100, make it kind of pretty, so it doesn't last forever, because it's going to take 100 million iterations to do it now. So let's go ahead and do that and see what happens. Oh, there it is. Look at, oh, pretty. It is pretty. So there it is. We have a little Mandelbrot set here, and it's actually done all the iterations and made a beautiful color map for me. So I kind of like that. This is pretty easy. If you notice, I haven't really written this code, right? This code was just generated for me. So let's try some other things. Let's try something simple. Let's, I don't know, generate a random list of letters with length n and def. Sure. Doing a random choice of letters, that looks good to me. Create, I gotta put a comment here. Create a histogram. Now let's do create and display. And display a histogram with 1,000 random letters. Oh, sorry, def. Sure, so this is, it's actually asking me how many letters I want. It's kind of rewriting some things for me, but that's okay. I don't really, oops, I forgot to hit tab there, so it didn't actually autofill. Let's try that. And let's type histogram. Just histogram. Let's do 1,000 letters. That looks good. Ta-da! It doesn't actually, it didn't label them. Okay, let's try fixing this a little bit. And label by letter. So let's dump this out. And see what happens when we do this. Def. Yeah, so this looks a little better. It does letter counts. It's zeroing everything out. It seems like it's going to label it. That looks like it might be right. Let me take a look at some other code options here. I like this version a little better, so I'm going to do that. Oh, dang it. I forgot to hit tab again. Yes, now I should hit tab and actually execute that. And now let's try this again, and it'll be a little bit better, I think. Oh, index error. So what did it do wrong here? Counts 26 zeros. So somehow it didn't like this very much. So I'm going to try this just again. I'll try the other version of the code. Let's try that. And again, I managed to fat finger this. So you notice the big thing that I'm having trouble with is that I'm having more trouble with just my own typos than I am with the actual system. So let me try this real quick and hit tab to accept, then execute that, and then we'll try this again one more time. Okay, so this is better. It's actually doing the little histogram of the letters. So this is just taking a random set of things, but it's still displaying some pretty nice things. So let's try something a little bit more sophisticated because I want to see if I can make this work. Let's see, create a function to calculate the force from inverse square gravity between, yeah, that's fine. Actually, we don't need between 2 points. I'm just going to hit return there. I'll do def, and it figures out the force. Yeah, so because I'm an astronomer, I'm going to actually change the gravitational constant to 1 because I just do that because, you know, that makes my life easier. I'm not going to get into the actual putting massive planets in there or anything like that. So we're just going to do that. Okay, and so it's doing it in terms of r, which is interesting. Now, I could have done it in terms of x and y, but what I wanted to do is just do this. And then we're going to do def distance I don't know. Let me define it first. I should write a comment here. Distance between two. Distance to a point. Let's just do this. We're going to just do integration at one point. I'll do def. So it calculated a little distance thing here using Euclidean metrics, so that's awesome. And let's do a generic. How about a fun? Let's not do generic. Let's do a RK4 function to integrate the positions of a particle in an inverse square gravity field. Def. You can do it. Ooh, did something. So it's doing RK4. Let's see if it's doing it right, though. Wow, that actually looks right. So it's actually doing all the different coefficients, x and y. It's doing the velocities and seeming like it's calculating those right. So it's actually calculating the forces. Yeah, that looks like that's probably right. It's at least mostly right. So it's going to involve a little bit of editing here. So we're going to go ahead and let me see if there's another version of this just for fun. Now these are pretty much the same. I mean, the problem that it's going to have is that it doesn't understand exactly what the force is. So we're going to have to do a little bit of calculation for that, I think. But it looks like it's doing basically the right thing here. So yeah, so I'm going to go ahead and accept that, and then we're going to do a little bit of editing here to fix it. So we're going to just say r is equal to distance, x and y and 0, 0, and we're going to say that, so that's going to work fine. And the other thing we need to do is calculate fix our little differential equation here and just say that this def f of, which is going to be, oh, well, shit, it just did it for me. Excuse me, but it just actually figured out what I needed to do. It's doing mostly the right things here. It looks like it's doing mostly the right things. It's not really resolving the components in quite the right way. So I'm going to just take this out. I thought that I needed to do some more editing, but there we go. And let's see if this works here. So this is calculating the force. The thing that's fascinating from my point of view is that I'm spending my time reviewing the code that's been written rather than writing the code that's been written. So I'm spending time not actually generating code from scratch, but looking at it, kind of saying, well, what is going on here? So for me to understand this a little bit better, I need to break it up a little bit. I'm going to break this up into here and break it up here so I can see this a little more clearly. And what it's certainly doing is taking the x and y positions and then integrating them in Vx and Vy. It looks like it doesn't seem like it's decomposing the forces correctly. Yeah, so I think there's going to be an error in this, and I think the thing that it's going to be doing is doing an error with the forces. I think it's not integrating the x and y forces correctly. So it seems like it's kind of trying to do this here. But I think what I need to do is fix one minor thing here, and I think what I need to do is return this as, like, I'm going to return this as a vector, and I think what I can do here is copy this and kind of do this, and return it as a 2-element vector. I think this will work. And then I'm going to just change this to 0, because I'll take the 0th element and I'll take the 1 element. This is like horribly inefficient, but that's what we're going to do. 0, 0, oops, 0. And when it's returning this, it has to return more than this. It has to actually return everything. So we're going to do, for this thing, it's returning X, it's returning Y, and it's returning V. Okay, it should be returning the same thing. Yeah, that looks a lot better. Vx and Vy. And let's see if that works. Okay, that seemed to work. All right, so let's see if this is going to go. Integrate the orbit using RK4 over time. And return this as a list of positions and velocities. Def orbit. Okay, let's see. We're putting the positions in, we're putting in the ranges in, and we're doing like an orbit. Yeah, sure. Okay, looks like that might work. Let's give that a shot. Oops, I actually, again, fat-fingered this. Let's try that. Let me see if there's other versions of it just for fun. Oh, I like that first one. That seems cleaner. Let's try that. And let's try doing this. Orbit. Sure. Orbit data. Let's call it orbit data equals. So let's take a look at our parameters here. So Vx and Vy, we're starting at 0, 0. I hate that. So let's do this again. Equals. And I'm going to hit accept here, and we're going to change this a little bit. This is 1. And I'm going to put this as -1. So actually, minus 0.4. So I'm picking the y position to be, or the x and y position to be 0 and 1. I'm picking up the velocities. I'm setting up a time step. I'm integrating this as through the RK4. And let's see if this works. Let's take a look at orbit data. Orbit data. No, I just want to display it, dude. Just show me the data. Show me the data. Ooh. Well, that looks promising. Let me actually see what happens when I do, I don't know, plot x and y from orbit data. Yeah, sure. Did we get it wrong? Orbit data. Let's try that again. Plot x, y from orbit data. Not going to do it. Okay, plot. It likes that, so let's try that again. Let's try x equals orbit data. So it doesn't like it because it's a tuple. Well, pooey. Let me think about this just for a second. Okay, so clearly the problem is that it's not a NumPy array. So OD is equal to np.array sub orbit data. Okay. Now let's try it. Let's plot OD. Plot. Let's try that. And it completely failed in terms of the orbit. But the principle behind it's pretty cool. So I obviously have some trouble in terms of how things work. Let me increase the mass here to something a lot higher. Let me take this out just because it's just annoying me. So clearly I have a problem associated with this. I'm not exactly sure where the bug is. It looks like the forces are still negative. It looks like everything is going. But it's going to take a little while to debug it. Anyway, this kind of shows both the potential and also some of the limitations of this. I mean, writing this kind of code is tedious and annoying. I spent time doing the debugging of the code, which was a little less tedious and a little less annoying, but I obviously have to spend a little bit more time doing it. So it isn't the cure-all for everything, but it is also kind of just amazing how rapidly you can write things based on describing your intent. Now, I will say as a full disclosure, the Mandelbrot set, I have played with this before as an example within the software, but I think it still shows kind of the power you can do just by explaining what you want to do and then doing it. Thanks a lot for watching. Have a good day.